Hey there, in this video we're looking at factoring trinomials in the case that our leading coefficient a is not equal to 1. For example, in this trinomial here, we've got a equal to 10, b equal to negative 21, and c equal to positive 2. Remember, those three coefficients, a, b, and c, are just the numerical part of these terms, not with the variables. So we can see that a is equal to 10, which is obviously bigger than 1, but one thing we could try is maybe it's possible there is a common factor that we can divide all of these coefficients by to make them smaller. However, in this case, there is no common factor we can divide by because, well, 10 and 2, those have a common factor. We could divide those both by 2, but this 21 is not divisible by 2. So there's nothing we can divide by in this case. We still want to check though. So now we're going to move on to our second step. If we still have our leading coefficient a that is not equal to 1, we want to solve this number puzzle with two factors that multiply together to equal a times c, which in this case would be 10 times 2, so that gives us 20. And we want our two factors to add up to b, which is negative 21. So if we're trying to multiply to make a positive number, we could multiply a positive times a positive or a negative times a negative. But looking at this negative 21, since that is a negative, that tells me that I'm going to need to multiply a negative times a negative so that when we add those factors together, we still get negative 21. And negative 1 times negative 20 equals positive 20, and if we add those together, we get negative 21. So we solved our number puzzle, finding those two factors. Now we're going to move on to step 3. This term that's in the middle of our trinomial, this negative 21x, we can split that up using this negative 1 and that negative 20 we had. So we're going to keep our leading term the same, 10x squared, but this negative 21x, here maybe I'll just rewrite this down here so I have a little bit more space. So this negative 21x, we're going to split apart into negative 1x, or just negative x, and negative 20x. And we're able to do that because negative x and negative 20x are like terms, so if we did combine those together, we would just get back to this original negative 21x that we had. So what we've done is we've taken our trinomial, our three terms, and now split them into a polynomial that has 4 terms. That's helpful because we have a method we can use to factor 4-term polynomials. We can factor by grouping. So we'll split this into 2 groups of 2 and look for a common factor in each group. In our first group on the left here, our leading term has a coefficient of 10, but our second term has a coefficient of negative 1. So there's no number bigger than 1 that we can divide both of those coefficients by. But we can still divide both of those terms by x because x squared does have x as a common factor. X squared is just x times x. Looking at our second set of terms, we cannot factor out x from these terms on the right because our final term, this plus 2, does not have x in it. But if we look at these coefficients, there is a number we could divide those both by, negative 20 and 2 are both divisible by 2, and if the first term in a group is negative, we want to factor that negative out with our GCF so that we can get back to having that first term be positive. So now we're going to divide this set of terms on the left by x and factor that out. When we divide terms by x, that's going to make our exponents get smaller by 1 power of x. X squared divided by x still leaves us with 1 copy of x left over. We haven't divided by any numbers, so our coefficient 10 stays the same. And if we divide negative x by positive x, that gives us negative 1. From our second group of terms, we're going to divide both of those by negative 2. So now we're just going to divide the coefficients. Negative 20 divided by negative 2 is positive 10, and we still have x in that term because we did not divide x in the second group. And positive 2 divided by negative 2 gives us negative 1. We can see now that the pair of terms that is left over in each group is the same. So that means that our factoring by grouping was successful, and we can regroup all of this together. We can apply the distributive property to regroup this all together, which says that if we're multiplying these two different things, this negative 2 and this x, but we're multiplying both of those by the same thing, 10x minus 1, well, that's the same as if we put the x minus 2 together into one factor and multiply that all by 10x minus 1. So that is the pair of factors that we get from separating the original trinomial that we had. First, we solve our number puzzle so that we can split that middle term apart and get a 4-term polynomial, and then we finish using factoring by grouping. Let's look at one more example, factoring a trinomial where a is not equal to 1. So if we start with our first step, let's check and see if there's a common factor that we can divide all of these terms by. Looking at the coefficients, 18, negative 24, and negative 10 are all divisible by 2. So we can divide each of those terms by 2, and we can actually also divide every term here by x, because x is a factor that shows up in all three of these terms. So we're going to divide each term by 2x, and when we do that, the coefficients are all going to be cut in half. So we have 9, negative 12, and negative 5. And our variables are going to get smaller by 1 power of x. So x to the third will become x squared, since we've divided out one of those copies of x and put it outside the parentheses. X squared becomes x, and the x that is in this last term gets divided out, so we're just left with a coefficient negative 5. So that makes the rest of our work a little bit easier because these numbers are going to be smaller when we're doing calculations, but we still are left with a polynomial where a is greater than 1. And there are no more common factors that we can divide by, so to finish this off, let's continue with our method, and we're going to find two factors that will multiply together to equal a times c. A times c is 9 times negative 5, so that gives us negative 45, and we want two factors that we find to also add together to equal b. We can use negative 15 and positive 3 to solve that puzzle. When we're multiplying a negative times a positive, we get a negative, so that works for our negative 45 up here. And when we add together a negative and a positive, if the negative number is larger, then our final answer will still be negative, so that's why we're left with negative 12. We've solved our number puzzle, and now we're ready to move on to step 3. We're going to take this term in the middle, that bx term, and separate it out into the two factors that we found, negative 15x and positive 3x. So we still have the original 2x that we had factored out at the beginning of that problem, and we're not doing anything yet with this 9x squared, but this negative 12x we're going to separate into negative 15x plus 3x, and we still have negative 5 at the end. I should also mention here that the order of these terms in the middle does not matter. If we had written this as plus 3x minus 15x, we would still end up with the same factors when we're done with our problem. It's just some of our steps in the middle when we're doing our factoring by grouping would be in the opposite order. But of course that doesn't really matter when we're dealing with addition or multiplication, because both of those operations are commutative, meaning that a times b is the same as b times a. So we can do that in either order. Let's finish factoring the rest of this on a new screen so that we've got a little bit more space to work. So we're going to use factoring by grouping to factor these 4 terms that we have left inside the parentheses. We don't need to do anything with this 2x that we factored out because after we factor out a common factor, we can just continue to work with the terms that are left over in our parentheses. So if we find the greatest common factor from this first group, looking at the coefficients, 9 and negative 15 have a common factor of 3, and both of these terms have a variable x in them, so we can also factor out that common factor x. In our second set of terms, there is no x in the negative 5 here, so x is not going to be a common factor. And if we look at the coefficients here, there's actually not really a common factor of 3 and negative 5 either. So in that case, we're not really going to divide by anything other than 1. In our first group, if we divide by 3x, we're going to divide the coefficients by 3. 9 divided by 3 is 3, and when we divide x squared by x, we're left with x. From the second term, negative 15x, if we divide that by 3, we get negative 5, and the x cancels out. X divided by this x that we've now factored out is equal to 1, so we just have negative 5. And we said we're not really able to divide anything in this second pair of terms, so we'll just rewrite that with a 1 outside of our parentheses here. Even though we're not dividing by anything, it still is useful to write that 1 here, because now when we regroup this using the distributive property, that 1 is going to be needed as the second term in this pair of factors, 3x plus 1. And the matching set of terms, 3x minus 5, we will move into one set of parentheses using the distributive property. Those are now both being multiplied by the 3x plus 1 that we have here. And don't forget, we still have this 2x that we had factored out at the beginning of our problem. So that common factor will just remain outside of those other terms. And the final factorization of this polynomial is 2x times 3x plus 1 times 3x minus 5. Now, I did mention earlier that we would still get the same final answer if we had used grouping but written those middle terms in the reverse order, if we had done plus 3x and then minus 15x. So if you'd like to see that for yourself, I encourage you to practice using factoring by grouping to split up this 4-term polynomial, and you should see that even though your steps in the middle here will be in the reverse order, you will end up getting the same final answer.